right, welcome back everybody to another episode of ITProTV. I'm your host, Don Pezet, back again with another episode of CompTIA IT Fundamentals. And in this episode, we're going to be exploring the wonderful world of network cabling and connections, talking about the hardware side of networking, which is a pretty exciting topic. And here to guide us through the whole process is Mr. Ronnie Wong here in studio with us again. Thanks for joining us, Ronnie.
Well, Don, thank you for having me back as we continue on taking a look at this idea of different network connection types that we need to be a little bit familiar with if we're going to be entering into the world of networking itself. And we're also going to talk about some basic internet connection types as well. So we've got a lot that we want to cover and address. So that's what we're going to get started in, is just making sure that we understand how our network's actually going to work together and build the pathways that we need.
All right, now, Ronnie, I've been working in networking for many years, and I know there are a ton of different networking cables that are out there. We could probably spend hours going over all the different cables, but the reality is the amount of cabling types has really reduced over the last decade, really,
Easily.
as people have transitioned into wireless. So the world out there of network cabling is a lot smaller than it used to be, right?
No doubt. So at one point, right, we had to deal with things like the coax cables that were out there, along with so many different other cabling standards, but it's kind of reduced it down to, well, really two different cables that we tend to end up using today in networking. So we're going to make sure that we focus in on that. But even before we do that, right, there's two broad categories, just like what Don was mentioning. There is the world of the idea of cabled networking, which means that we are going to be bound or tethered by some type of physical cabling, or that world of, well, pretty much what we call unbound cabling, right, or unbound media is what we talk about it in the sense that we're still networking, but we're not having to use cables anymore. So when we talk about the idea of cabled connections today, the most common type of cable, and we're not going to get too detailed in this, is one that looks like this, okay? And there'll be two connectors on the end, and these will end up fitting into some type of modularized jack. So here's an example of one, and it's simple. Once we plug that in on both ends where we hear that snap on those devices, if they are designed to be networking together, well, we'll be able to send data over that link that we've actually created to be able to do so. But that's not where it began, right? So for us, in terms of networking, it really harkens back to the majority of us coming back to telephone days is where it comes into. So let's take a look at my screen and I'll show you what I'm talking about. So I just want to show you an actual physical cable that was there, but here the details are actually right here when we do this. So inside of the actual cables that we tend to use, there's really three different components that we're talking about, right? There are, of course, individual strands of cable that you can see, and these are marked by colors in here. There is also this jacketing that keeps all those individual strands together. And then there is this, which is our connector. Now, this particular connector is back from the days of the regular telephone line, and we call that just an RJ45 connector. RJ11 connector. See, I'm getting them mixed up because I haven't used one in so long. It was actually funny because I was trying to find one of these around the building the other day. I was like, you want to know something? I realized something. We don't actually have any of these jacks in our building anymore because everything's gone to the new RJ45. So you would see something like this, and then on the wall, or this one actually is a modular connector over here, and you'll see it has these 4 pins here, and it snaps into place just like I showed you a little bit earlier with the RJ45. So this one is really designed to connect us into the telephone network, and that's where we first probably really did start to do some internet connecting, was over the telephone lines as well, okay? So this one allowed us to be able to connect when we were actually doing this, but it required us to use a modem if we were connecting our computers to the telephone line. Well, everything our computer did was digital in its origin, and it sent out a signal digitally. But the telephone line, though, it had a different type of signal that we call analog, and those two are not going to be able to talk to each other unless they have a device that allows us to translate that signal into what we actually need it to be able to do. So that's why this is an important connector for what we're doing. And in terms of networking today, we don't tend to see this in regular data networking, but it's still existing out there if you are going to be, using the internet. In other words, because it's so universal out there today, telephone lines still exist just about everywhere. And if you need a backup, this might be the way to go.
And a little later in the episode, we're going to talk about broadband. And one of the types of broadband is DSL. DSL does still use regular traditional phone lines. So you'll see those RJ11 connectors and traditional phone jacks still in use in some places, but far less common. And Ronnie, you mentioned how like RJ45 is pretty much the same. The plugs look very similar, just one's wider than the other,
Right.
and that's kind of the common one that we're going to go to.
Yeah, the most common one that you'll see in today's networking and just about everywhere, if you know that there's some networking in the building, it's going to be using what we call an RJ45, a registered jack 45. And you'll notice how these pins are numbered for us. Well, there's actually 8 separate wires that actually allow us to split this off, and they each align to each one of these pins. And so this connector right here is that RJ45 by comparison to the 4-pin connector that we were just looking at, which is going to be that RJ11 connector too. And it will also end up having a jack or a female plug, I guess is what this one's technically called, where if you take a look, you can see internally where this one is also going to be cabled in, and we just simply snap and it locks into place here, and we are good to go. Now, in terms of the cabling, it's going to be regular copper cable that's inside of these types of connectors, and these wires that we end up using, and they allow us to run pretty good distances. So for example, a single type of cable that normally uses a connector like this, usually the maximum distance is somewhere about 300 feet or so, 328 feet, I think, or 100 meters is what you'll see. So you can run these a pretty good distance. Now, it doesn't mean that it's going to fail if you run it a little bit longer than that, but the standard is saying here's where you'll get at least guaranteed good delivery of the signal from that physical cable. You know, if you actually run a single length of this in between 2 different devices that's actually networking, that's what you'll end up seeing. So those are by far the 2 most common that you'll end up seeing today. We don't tend to see a lot of the coax anymore in as far as the cables that we run inside of our own networks, but where we might see them is what Don was hinting at, the idea of broadband connections. When we start talking about cable TV or cable internet access too, we'll see it there, but not normally inside of most networks today when we start seeing it. But this is not the only type of network connection that we have, but these are by far the ones that are cabled together that we wire the building with. It's probably going to be something like the RJ45 connectors that we'll end up seeing, and the cables that also go in that too. Those cables are graded. They're different for what runs in the side of the walls versus what we have outside of the walls too.
All right, and you know, one of the reasons why we see far less cabling these days is because we are starting to see a bigger trend, a movement towards wireless. And so, you know, you have Wi-Fi, which we've talked about in other episodes, and we have other wireless technologies that act as a networking service as well. So if you've got wireless, you don't need cables, and that's far more convenient, but not exactly the same, right, Ronnie?
Right. When it comes down to the idea of different wireless connections, we did talk about the idea of Wi-Fi and what it grants to us, that ability to be able to connect regardless of where I am. As long as I'm within range of wherever that signal is coming from, I will be able to make the connection. I don't have to worry about being tethered to one location. But that's not the only game that's in town in terms of wireless. For us, there's actually different types of connections that we can also make depending on the devices too. So one of the more popular standards that you may see is one that's called Bluetooth, that allows us to connect these devices together without needing to understand a lot whether it's on this particular frequency or on that frequency, whether there's interference on those different channels. We just turn it on, and then we make sure that those devices at the end do connect. And once they're connected, they'll stay connected, and they'll allow us to use those devices too. Now, when we talk about Bluetooth, the neat thing behind it is you and I don't have to know anything really about the Bluetooth technology unless we're supporting it. And there are some different standards to Bluetooth that give us better battery life, that may give us a little bit more distance than what we need. But overall, though, usually when we turn on Bluetooth on both of those devices at the end, they'll ask if we want to make sure that they connect, and they'll connect right up, and they'll be able to actually talk to each other and be able to use that as well. We take a look at my computer, I can at least show you an example of this connection if it's actually still up and on. Actually, mine turned off here for a moment. Let me show you on here. Let me open up my Bluetooth preferences right here. Okay, so you can see, like for example, oh, I don't know why my home trackpad is still connected because I'm pretty good distance from my home, but it does show that it's still connected at this point. So you'll see that here's a device that it's actually finding that it's connected. Actually, this is the one I ended up bringing into work, so I'm lying to you. That's why it's here. Okay. So the home trackpad is connected from right here, and there's another device that I have, and it has this symbol on it. And the only thing I did was turn it on. When I turned on the Bluetooth signal, and on this device, like the trackpad, it began to find and discover it. And all I did was select it and tell it to connect, and it made that connection, that link in between, and it's now joined, and I don't have to worry about the connection anymore to be able to do that. Now, other devices, if they start showing up, they'll show up here too, and you'll start, oh, here's one. See, here's a Samsung TV, and you see exactly what I'm talking about here, where it's actually trying to connect. I didn't intentionally try to make that connection. It's now discovering other devices that are out there, and it will use this this particular Bluetooth standard to help us to do this. Now, Don, do you know a little bit about the history of this Bluetooth, what they call rune here? It's kind of a little bit neat. We'll not go super deep into it, but it's kind of neat here. The guy was a Danish king, Harald Bluetooth, okay? And he actually had a Bluetooth from eating blueberries, of all the things in the world that you could actually do it. So kind of strange here. But he established this idea that there were too many different like trade languages that were inside of that kingdom. So he said, no, here's what we're going to do. We're going to put everything under one standard. We're going to make all the trade, the commerce in this one language so that there's no misunderstanding between all these different peoples that are now trading, inside of Denmark. And that really established that commonality of that language in between all these different people, and the Kingdom of Denmark continued to flourish during that point. Now, this is back in 900 something. So it really did. It advanced their kingdom pretty much. And they decided to name this in honor of Harald Bluetooth, because they're saying, look, if all the devices would just adopt this as a kind of common language in between these devices, you don't have to know what's actually in the background. Everybody will be able to negotiate and communicate the way that they need to. So neat signal.
Now, Ronnie, what you were showing there, like with your trackpad, right? I don't really think of that as networking. I think of that as just an accessory that's attached to my computer. So can we use Bluetooth to connect two laptops together and exchange files and use it just like a regular network?
Yes, you can. Now, it doesn't mean that you'll get all the same speeds that you might get on a regular network cable together. But yeah, even between this device and my laptop, it really just feels more like a peripheral at this point. But yes, you can connect these devices. And Don, I use this sometimes when I take a picture on my phone, and I might need it for a show, right? Then I go around the building, I take pictures like, oh, I can put it into my Dropbox and do this, but I can just turn on Bluetooth here and the one on my phone and just have it transfer. And it's not a huge file. It works very quickly and works very well. But as large, it does take a bit of time to be able to do the transfer that we need to. So it allows us to connect very quickly without a lot of need for a bunch of setup. All I have to do is turn on both of those devices, and it finds the other device. We're just about ready to go and ready to connect. It does have a range limitation on some of the standards as well. So usually you start dropping the signal somewhere about 30 or 40 feet. If it's actually like right on the edge, it might come in and drop off. But you will see these types of connections too. So they are available on a lot of the devices today that will allow us to do this. Now, Don, I also use this in my car, because I like listening to things like on my Amazon Music account that I have. But I have a car that's old enough that doesn't have that directly built into the radio. So I have a little antenna on the other end, and I don't have to do anything. I just turned it on, and my phone immediately found it, and it said, hey, do you want to connect to this device? I just tapped the device name, and it connected right away, and then it allows me to play my, my gigantic playlist of 8 songs that I listen to, over and over again. But that's what it does, okay? It's really a nice technology that allows us to do that. We don't think about it as networking by far, like your traditional networking, but it is. It's creating that network between those two devices.
Now, Ronnie, you mentioned your phone, right, and transferring files there. I know on computers and on most phones, Bluetooth is pretty ubiquitous. You pretty much always have Bluetooth, but there are other emerging wireless technologies out there like NFC, and are you seeing that a lot? Does that act like a network as well?
It does to a point, right? But the problem with NFC, I shouldn't say the problem, the limitation with NFC, which is the near field communication, that technology is exactly what it says. It's really a narrow length that you can cover. So Bluetooth sounds fairly limited to me, Don, in 30 feet or so, somewhere around there. Signal can come, it can drop, it can do everything. NFC, though, has actually been out there for a while. And here's you actually see where it depends on where you read the standard from. So it says maximum of 10 centimeters. Now, Don, if I remember my math right, that's like 4 inches or so.
It's a very small distance.
Yeah, it's fairly small. So where do you find its application? That when you start to talk about the use of near field communications, within 4 inches, I don't know any networking device, Don, that I really want to stand that close to make sure that something like this happens. But it is out there because of things like payments that you can do, like the Apple Pay and what's the other Android Pay,
or Google Pay now. They
Google
changed its
Pay,
name.
and so these things allow us. And I've seen the commercials for like the Samsung Pay where they just walked up and put their phone directly on the device and it automatically did that. And I think I might have,
Samsung had a similar feature with their phones where you could, at the end of the day, you go home, you could take your phone and just set it on your laptop. And so, actual physical contact at that point. But NFC would trigger a communication, and they would see they were each there, and then they would negotiate a connection over Wi-Fi, and it would sync all of your pictures.
Nice.
So you could just quickly sync all your pictures like that. But it had to flip over to Wi-Fi because NFC is not only short, it's pretty slow as well, right? It's not designed for huge amounts of data.
Yeah, if you start to take a look, for example, on this, it really does depend on what standard that you read. So some of them will tell you it's like 4 centimeters, and this one here says 10. But notice the max communication between them, right about half of a megabyte, maybe, or a millibit. So 424 KB. I have to look here. Is what it's telling us. So the further you away, so if you're right at that 4-inch limit or so, that 10 millimeter, it might even be slower than that for all you that you know. And then the closer it might get up to those speeds. But these are all theoretical speeds that you tend to see. So if you have large files, it's going to take a long time. So the idea of what Don was telling us, where it switches over to Wi-Fi instead, you're going to get a much better transfer in that way. But I am seeing that application is where you have the Apple Pay and that stuff like that. That's what it does. Now, if you're having it on these smaller devices like smartphones, the key here, though, is it can wear out your battery too, because it does generate a lot of activity where it drains your battery down. So you might have to be a little bit more careful about keeping the battery charge up too.
And those are some of the big differences we have to choose. Like, let's say you're building your own network, right? And you have to make a choice. Do I want to do a physically wired network, or do I want to do a wireless network, right? On a physically wired network, you have a consistent guarantee of speed, right? It's always going to function at that same speed, and it's private. It's just you communicating over a wire. It's hard for somebody to intercept that. With wireless, you have a lot of convenience, but you don't have a guarantee of speed because it's going to fluctuate based on other people communicating and whether there's obstacles between you and the receiving antenna. And you also have a little bit less privacy because people can intercept that signal over the air really easy. But that convenience factor is so important, right? And most people will say, what do I care about privacy? We can encrypt our data and that solves that. And instead, I get the convenience of wireless. So you are seeing wireless deployed darn near everywhere. And today, it's pretty rare for you to sign up for broadband access like cable or DSL or whatever, where when the cable or internet company comes in and puts that router in or modem in, it usually has wireless built right into it. So they're basically giving away these wireless networks, and that's made it become pretty standard. Like that's the network people are going to go with, or they end up mixing. I know I mix at home. My home network, I have wireless, which I use for my cell phone and tablets, but then I have wired, which I use for my television and set-top boxes. So I want them to be able to stream high-speed video or high-quality video reliably, versus my cell phone, where I don't mind if it takes a couple extra seconds. I want the convenience of not having to plug in a cable, which now that I've said that, it's not even really possible on my cell phone. I don't know about yours.
Nope. Yeah. So it's amazing on these wireless technologies that we're talking about, because it really does set us up for what we've been talking about as well, or what we're going to be talking about now too. Don emphasized the idea of speed, right? So how do we know what speed actually means? You might hear that term, and just like I pointed out on my screen there where it said like KB and stuff like this, so right here, what does that really mean when you see like KB/S here? Well, that's kilobits per second. Now, we don't really know exactly what that means in terms of what we're sending or how much we're sending, because it's a hard measurement, because we don't normally measure speed in terms of per second things, unless you were actually doing a lot. But for here, let's go and do a speed test. And on my machine, I went ahead and on Google here, I selected speed test. And right here inside of Google's own web page, I can run the speed test. And now it will generate and it will start showing me some of these different connections that we're seeing. And you can see right now it's looking about 81 or 80 megabits per second. So what does that terminology actually mean here? For download, it looks like it went to about 71 megabits per second, and then upload here looks like is what it's calculating now. So what do these numbers really mean in terms of what we're trying to do? So upload, download, you start seeing these numbers and the terms here and the actual abbreviations. Mbps, you start seeing that. Well, let's go ahead and see if we can make a little bit more sense out of this by we'll just use a simple text editor to help us, okay? So when we start talking about the idea of bits, right? A bit is either a 1 or a 0, okay? So is what we actually end up with, right? So if I actually was transmitting something like 1 bit per second, okay? That would be either a 1 or a 0, okay? Each second. All right, so that kind of makes sense, okay? Now, what about the idea of a kilobit? Well, a kilobit is 1,000 bits here, so that would be about 1,000 each second. And then when we go to the term megabit, well, that's actually going to be, 1,000 kilobits. So that would be this each second. And then when we go from mega to gigabit, which is what you hear now today as well, that's going to be 1,000 ones of these. So this is going to be, 9 zeros? That's about 1 billion, right? If I actually counted correctly here. Yeah, okay. Each second. And even today, you might hear the term terabit, which would be 1,000 gigabits. So, Don, this is now getting up into the
trillions.
1, 2, 3, yeah. 3 and 1, 2, 3. There we go. Each second, okay? So now, trillions each second. Now, Don, I don't even know how to measure that idea of terms of trillions per second. And that sounds amazingly fantastic to me. The idea of 1 billion per second sounds really fast to me. But when we start talking about this, that's what's happening, is that we're seeing the increase here in everything that begins to happen when we go from kilobits here to megabits to gigabits to terabits. That's what's happening, is you're seeing this growth so quickly in terms of the amount of data I can send every single second.
And it's important to understand this, because one thing we have to be sensitive to when we're working with a network is that if you're on a wireless network, it might seem fast. You might be really happy with your experience, but it's significantly slower than a wired network. In a wired network, one where you plug in a cable, like what Ronnie showed here, when you plug in one of these cables, today it is cheap and standard for this to be gigabit speed. So you're able to push that billion ones and zeros per second. Like, that is a huge amount of ones and zeros. When you're on a wireless network, though, wireless networks rarely break the 200 megabit realm. That there are some, you can go out there and you can find, they've got very specialized wireless routers that can hit a gigabit right now. But your average one, the one that most companies or home users are going to run, will rarely break 200 megabit. In fact, most of them rarely break 50 megabit. So let's just act on the side of optimism here and say that I'm getting 200 megabit on my Wi-Fi router. Well, that is 5 times slower than a wired connection. So for a lot of people that are out there, they're saying, oh, wired is dead. Nobody's going to run wires anymore. Everything's wireless. Well, wireless is not as good as we think that it might be. Another challenge that we have with wireless, and we didn't really get into this before, and I don't want to get too technical on it, but on a wireless antenna, it can only send or receive one thing at a time. It can't do 2 things at the same time. So the more people on your wireless network, the slower it gets. Not because it's moving less ones and zeros per second, but because you're having to take turns accessing the antenna. And that's why if you go to the store, you'll see fancy Wi-Fi routers that have like 8 antennas wrapped around them. They're trying to maximize the amount of antennas, and that's a way to get around that. Those are problems we don't have in a wired network. So wired networks are able of achieving insane speeds. And terabit, as of today, is not a realistic thing. You don't see that. 10 gigabit, 40 gigabit networks, those are pretty common. 40 gigabit, anybody can do it, but it's really expensive right now. So that's kind of what your maximum threshold is. But in time, given just a few years, the way technology advances, we'll be at terabit speeds on our networks.
Yeah, it's amazing to even think about that, because we are now talking trillions per second. So those are the actual speeds that we're actually seeing here, okay? Now, Don, I was a bit hopeful for our episode. I thought we were going to be able to get into connection or internet service types too. But Don, looks like I've talked a lot of time here on connection types. So we may have to actually end up on another part 2 at some point instead.
All right, let's do that. You know, what Ronnie's talking about there is we want to talk about cable, DSL, fiber, all the different ways we connect to the internet. we need to know what speed, which we've talked about here in this episode, and we need to know about connector types, which we've also talked a bit about. So it all goes hand in hand. So yeah, we'll definitely do a part 2. We'll tackle some of those and learn the differences. It is an important thing for people to understand because it's a decision that as a consumer you have to make, but even businesses have to make decisions on what type of broadband they're going to use for their networks as well. All right, well, Ronnie, before we wrap up this one, do you have any parting words for our viewers?
Well, just remember, right? If you're considering the idea of networking, these are some of the terms that we've been using and some of the technology that you want to become familiar with. And if you find this to be fascinating, like I did, then jump right into it. And this may be a good choice for you. But at least now you have a sample of some of the things that you'll be looking at, and there, of course, is going to be more to come.
All right, well, ladies and gentlemen, that's going to wrap up this episode of ITProTV. So we had a chance to talk about cable connectors, and we talked about wired versus wireless communications and the various speeds that are out there. Stay with us for part 2. We're going to tackle internet connection types, DSL, cable, all that good stuff. It'll be a load of fun. Be sure to stick with us. Ronnie, thanks for being in the studio with us. And for you viewers out there, thank you for watching. Signing off for ITProTV, I'm your host, Don Pezet.
And I'm Ronnie Wong.
And we will see you next time.
Thank you for watching ITProTV.